Hi, welcome back to another video, and in this lesson, this is a continuation of college algebra, and we're going over the transformations of functions, chapter 2.5. All right, anyway, let's just jump right in. Okay, so take a look at what we have here. It says use the graph, and we're gonna go over everything as we go. Okay, it says use the graph y equals f of x to graph the function g of x is equal to f of x plus 4. So basically, this original thing right here, this original graph, like I know it looks weird, it looks like a rotated z. This is your f of x. F of x, you can think of f of x as your original function. So that's the terminology that I'm going to use. G of x would be your secondary function. It would be um, a tweak to the original function. So as you can see, this is f of x. And they said that g of x, which is your second function, is going to be your first function, which is f of x, your original function, plus 4. So, let's establish some ground rules. I want you to get the topic of something that is outside. So we have outside, and then we have inside. Okay, and you're going to see what I mean. But I really want you to know that the outside changes the y. And we'll make a little separator right here. And the inside will change your x. Now, it can be anything from translations, like adding and subtracting, multiplying, even dividing, which, multiplication is technically division, right? If you can master this concept, that the outside changes your y and the inside changes your x, you'll be golden, okay? So for this one, for example, so we have, I guess we don't need all this space. Let's clean up just a little bit. Yeah, we just want to, we just want to know what we're dealing with here. So let's take a look at the first example. So the g of x, so g of x is equal to your f of x. So it's everything from f of x, but you're going to add 4 to it. But add 4 to what? So take a look here. What I mean by inside is and outside. I'm considering anything inside of a parentheses, a square root, an absolute value bracket, anything like that. I'm considering that to be inside. So if it's inside this here, like you see, we have an x in there, right? There's nothing there. There's no pluses, no minuses, no funny business going on. It's just an x. So I'm considering this the inside of the function right here. So if you see anything going on in there, it's going to affect your x's. On the opposite side, we also have an outside. So what I consider outside is something that may be, let's put a different color, something like maybe sitting right here next to the f of x, or even right outside of here, wink, wink. That would be my outside. So if you see anything outside of those parentheses, is going to affect your y. And that's the whole concept, okay? So you see we have a 4 outside. So basically, we're going to go ahead and we're going to add 4. You see, this says plus 4, right? So we're basically going to add 4 to all of our y's from the original f of x. And you're going to see it's a cinch, I promise. So let's go ahead and make an xy table so you can see what I mean. Let me make sure you guys can even see that. Yeah, okay. So we have an xy table here. So just put x and y. And from your f of x graph, like from your function, right? From the original, go ahead and pick a few points. You can see we have here -4, 0. That's a solid point. So we're going to put -4, 0. And we also have -2, 3. So -2, 3. We have 0, 0 right there in the middle. So 0, 0. We have 2 for x, -3 for y. So -2, I'm sorry, +2. Come on, I can do better than that. All right, +2, -3. So just put 2, -3. And then we have 4, 0. And let's extend this a little bit more. There we go. Okay, so now what do we do? Well, because we have something that's outside of the f of x, right here, like right over here, we want to do whatever they say. We have a plus 4, so we're going to add 4. But to what? To x or y? Well, it's outside, so you're going to add 4 to all of your y's from the original function. And that's the idea. So I'm going to squeeze it right up in here. So this is my f of x, right? And I want to make a g of x. So it's going to get its own xy table. Now, mind you, we're not doing anything to the x's, right? Because there's nothing going on inside of the function. So the x's are going to stay the same. -4, -2, 0, 2, and 4. But what are we going to do to all of our y's? We're going to add 4 to them. So we're going to take this 0. 0 plus 4 is 4. 3 plus 4 is 7. 0 plus 4 is 4. -3 plus 4 is +1. And then 0 plus 4 is 4. So this right here, this is your new graph. Okay, so all you have to do is plug those numbers in and find them on your xy coordinate plane. So I guess we can do it right here. Why not? And then we'll just match it up. So as we get more comfortable, I'm gonna go ahead and just move a little bit quicker. Let's see, the highest is 7, so we'll do 7, 2, 3, 4, 5, 6, 7. Just do a 7 by 7. And all we did, we just wrote the original. We wrote the original function. We picked out some points from there. It has to be on the graph, like right on the money. Okay, you don't want to choose any fractions or anything that's too troublesome. But anyway, all we did to go from f of x to g of x, we just add 4 to all of our y's from the f of x. So here's our new function right here. So we have -4, 4, so 1, 2, 3, 4, and then +4, that'll be somewhere here, right? Somewhere. Then we have -2, 7, so 1, 2, and then 1, 2, 3, 4, 5, 6, 7, somewhere up there. We have 0, 4, so 1, 2, 3, 4. And then we have, let's do that in a different color. We have that here, that's better, right? Okay, and then we have 2, 1, so 2, 1. And last, we have 4, 4, so 1, 2, 3, 4, 1, 2, 3, 4. They're going to meet right there. And all you do is connect your dots. And that's it. So whichever one closely resembles this, remember the points that we have over here has to match with whatever's inside of the graph, the answer choice. So we're done. Let's go ahead and match it up. Which one closely resembles what we have? It looks like is this one. So let's go ahead and click on here. All right. Do we have -4, 4? So 1, 2, 3, 4. 1. Yep. There it is right there. Do we have -2, 7? There it is. -2. So 1, 2 up 7. Yep. Do we have 0, 4? Got it. Do we have 2, 1? Got it. Do we have 4, 4? Got it. This is it. This answer is B. Now, notice the relationship between this and the original. Really quick. Well, let's go ahead and get the answer right. Yeah, fantastic. Let's stay here just for 1 second. I want to show you guys something. Let's change the color, and we're gonna plot the original. We should have plotted the original, but I just wanted to show you, a brand spanking new, brand new graph for the g of x. Let's go ahead and plot the points that we got from the original. -4, 0, 1, 2, 3, 4. I can't really see that. Let's use lime. And then we have -2, 3, so 1, 2, 1, 2, 3. And then we have 0, 0, 2, -3, 1, 2, 3. And 4, 0, 1, 2, 3, 4, bam. And here is our original. And as you can see, all they did was shift up vertically 4 units. So from here to here, if you go up 1, 2, 3, 4, you're there. From here, 1, 2, 3, 4, there it is. From here, 1, 2, 3, 4. So yeah, you see what's going on here. Like this right here between each and every point is just a vertical shift going up. Remember, vertical means up and down. Horizontal means left and right. This is a vertical shift because we added 4 to the outside, which is your y. And you're going to see they're going to give us every combination in the book. I looked ahead and I didn't see any horizontal stretches, so let us rejoice. That's one less thing to worry about. Let's go to the next one. Okay, so here we are again. Now we have x plus 1 on the inside, and you know that the inside will change your x. So let's go ahead and erase all of this mess right here. How do I want to do this? Yeah, I'm going to hit Control Delete. Yeah. So the inside changes x. The outside changes y. And what do we have? So, let's see. So g of x. Let's go ahead and write the functions down. I'm going to use lime. F of x. We're going to make an xy table for f of x. And this is just a preliminary. I'm just getting you guys accustomed to, you know, just the layout. Then you're gonna see we're not even gonna write the table anymore, really, if we can get away with it, or maybe we will. Who knows? Okay, so for our f of x, we're gonna have -4, 0. We're gonna have -2, 2. We're going to have 0, 0. You see, I'm just getting the corners of this graph. Like we have this corner, that corner, that corner. Let's keep going. 0, 0. We have 2, -2. So +2, -2. And the last point, we have 4, 0. Okay. Now let's get our g of x. So g of x, we'll use blue. It's going to have its own xy table. And we're going to have the same number of points. So, how do we go from f of x to g of x? Well, we have to look at the function. So g of x, as you know, is equal to f of x plus 1. Now, do we have something going on inside or outside of this function here of f of x plus 1? This is definitely inside because it's inside of the parentheses, right? So if, you know, that get into the habit of knowing outside and inside. So we know that we're going to change the x's because the inside changes the x. So it's like, we have an x plus 1 on the inside, but be careful. This is what's going to separate the boys from the men and the little girls from the women, okay? I want to jot something up here for the inside. I want you to do the opposite, okay? It can be very tricky. If you're at this point, I'm pretty sure that you've seen, you will see a plus inside, but then it actually means a minus. That's what's going on here, okay? Even though we see a plus, we're not going to add 1 to all of our x's. When something is wrapped up in parentheses, you remember we always do the opposite. Like something like this. Remember when we factor and we have something like x plus 3 and x minus 2 is equal to 0. Remember that section? And the answers are actually the opposite of what we have on the inside. So that's -3 and x is equal to +2. We take the opposites of what we see there. That's what's going on here, basically. Because this is wrapped up in a parentheses, we're actually going to have something, we're going to have the opposite effect. Essentially, instead of +1, we're gonna subtract 1 from all of our x's, and that's how it works out. So if you ever forget, think of a factoring problem when we had parentheses and the answers actually ended up being the opposite when we do the 0 factor principle. So you're gonna see we're gonna get more comfortable with it as we move along, and you're gonna see it's gonna work out very nicely. Okay, so anyway, so we already decided that we're gonna subtract a 1 from all of our x's from the original, from f of x. So there is nothing outside, right? So that means that our y is going to stay the same. So this is still going to be 0, 2, 0, -2. This is a 0 here. -2, and then we have 0. So the y's are going to stay the same because there's nothing going on outside. What about inside? Well, we do the opposite of what we see in there. So we're going to subtract 1 from all of our x's. So this is -4 minus 1, we get -5. -2 minus 1, we get -3. 0 minus 1, we get -1. 2 minus 1, we get a 1. 4 minus 1, we get a 3. And this is our brand new function. So, what does it mean when we subtract 1 from all of our x's. So do you remember, you know your xy axis, right? This is your x, this is your y. You know, this is +1, +2, +3, and so on, right? You know, we have something like this. Give me a second, just making my little increment tick marks here. Okay, so you know, your positive x's are this way. You know, as you go further this way, your x's get more positive. 1, 2, 3, 4, 5, you know, infinity, right? And it's the opposite effect when you go to the left-hand side. So there's -1, -2, -3. So if we're subtracting 1 from all of our x's, if you're subtracting, you're going to your left, okay? And how many are we going? We're going 1 from the left because we subtract just 1 from all of our x's from the f of x, right? Isn't that how we got the g of x? We did -4 minus 1, -2 minus 1, 0 minus 1, and so on. So this is going to be a shift over to your left. This is going to be a horizontal shift. Anything that affects the x is going to be horizontal. Anything that affects the y is going to be vertical. Because yeah, isn't x the horizontal axis going left and right? And isn't y the vertical axis going up and down? So get used to the terminology. You'll do fine. Okay, so let's go ahead and plot this. We have the original. I'm just going to go ahead and plot g of x. So let's use the g of x color. We have -5, 0, so 1, 2, 3, 4, 5. We have -3, 2, 1, 2, 3, and then 1, 2, like right there. We have -1, 0. We have 1, -2, and we have 3, 0, 1, 2, 3. Go ahead and connect your dots. It should look something like that. It should match up perfectly, and you're gonna see it is. Okay, so have faith in your mathematics. Where are we? Yeah. All right. So which one closely resembles? It looks like it could be A. So let's go ahead and enlarge that. And let's make sure that our points add up, that they match up. So we have -5, 0. So 1, 2, 3, 4, 5. Got it. We have -3, 2. Got it. We have -1, 0. We have 1, -2. Yep. And then we have, yep, this is it. It's got to be it. It's perfect. So that's it. We're just going to take the function. We have to identify whether there's an outside or inside change. Depending on that type of change, if it's inside, we're going to affect the x. If it's outside, we're going to affect our y. And take a look. We have something that is inside and outside. So we're going to affect both the x's and the y's. Okay, so let's go ahead and look at question number 3. So in question number 3, we have the original function. It's right there. So we're going to get the points in like 2 seconds. And like we have two different things going on. We have something going on inside. We have a -4, and we have a +2 outside. So we're going to change the x's and the y's. So first things first, let's go ahead and pick out the original function's points. So we're going to go ahead and make a little xy table. And let's get the points. So we have -4, 0. So -4, 0. We have -2, -3. So -2, -3. Take your time to take your time to get all of these points. We have 0, 0. We have 2, +3. So 2, +3. And then we have 4, 0. This is our f of x. Now we also have g of x. So let's go ahead and write our g of x in line. So we have another xy table. Okay, so, oh yeah, what is the function of g of x? The function of g of x is f of x minus 4, and then we're going to add 2. So let's close that up, and we're going to add 2. So what's going on here? Well, we have something inside, so that's going to change our x. And remember that we're going to do the opposite of what we see here. So we're going to add 4 to all of our x's. And outside, there is no funny business. If you see a +2 outside, you're going to add 2 to all of your y's. So inside changes x, outside changes y, right? So, it's not going to do any harm to actually write down what we're going to do mathematically. So we're going to add 4 to the x's. Too close. Talks. Add 4 to your x's. And we're also going to add 2 to our y's. And that's it. Just follow those 2 steps. Focus on one letter at a time, one variable at a time, and you should be fine. So let's go ahead and add 4 to all of our x's. So -4 plus 4 will give you 0. -2 plus 4 will give you a +2. 0 plus 4 would give you 4. 2 plus 4 would give you 6. And then 4 plus 4 would give you an 8. That's it for all of our x's. We're done with the x's. Okay, so let's go ahead and do our y's. What are we going to do with the y's? We're going to add 2 because there's a +2 outside, which is going to be a vertical shift going upwards. So let's add 2 to all of our y's from the original. So 0 plus 2 is 2. -3 plus 2 is -1. 0 plus 2 is 2. 3 plus 2 is 5, and then 0 plus 2 is 2. So let's go ahead to the multiple choice answers and see which one is going to give us what we need in all of its entirety. So we have 0, 2. So there's a 0, 2 there. There's a 0, 2 here as well. So it's either going to be A or C. So we don't even have to look at these because 0, 2 isn't, it isn't marked. So let's get another point. 2, -1. I'm sure that this is it. This has to be it. Yep. 1, 2, -1. Let's find this other point. We have 4, 2. So 1, 2, 3, 4 up to. Yeah, this is it. This is it. It's got to be that one. And that's all there is to it. All right, they're going to add the ante. Now, here's where the fun begins. We have a negative, but is it outside or inside? This negative is outside the parentheses, so the changes are happening outside, which means our y's are going to change. So let me go ahead and show you how to handle this. So first things first, let's go ahead and write down the f of x. We're going to write down an xy table for the f of x. What are the points? We have -4, 0. And take your time and write down the points, okay? We have -2, -2. We have 0, 0. We have 2, 2. And then we have 4, 0. Okay, let's go ahead and do our g of x. The function of g of x is equal to negative f of x. So we have x and y. I like the straight line tool. It makes things so much easier. Okay, so what do we have here? Okay, so do we have an inside change or an outside change? Well, we definitely have an outside change right here. So that's going to affect our y's, okay? But how? What's going on out here? Technically, we have a negative sitting in front, right? Isn't that technically -1 times that other stuff right there, times the f of x? It is. Whenever you have a number sitting, there is a number there. We know there's an imaginary 1 there. And when when numbers are right next to each other, we basically multiply. And that's what we're going to do. We're going to multiply all of our y's because it's outside. We're going to multiply all of our y's by -1. Now, there's nothing going on inside the parentheses. So all of our x's are going to stay the same. So write the same as that x's, okay? Now, but what about the y's? We're going to take all of our y's and just multiply by -1. So 0 times -1 will give you 0. -2 times -1 will give you +2. We get another 0 here. 2 times -1 will give you -2. So you see, we're just multiplying all of our y's by -1, and that's it. So this is, let's see, 0 times -1 is 0. So there goes our new graph. And let's go ahead and we're gonna draw this one from scratch because I want to show you guys something. We just stumbled across a reflection. So what's the highest number? We have four. We'll do a 5 by 5. So 1, 2, 3, 4, 5. I always look for the highest number. Like I see the highest number here is 4 in both, so I just do a 5 by 5. You could do a 4 by 4 as well, but you want to fit all of your numbers, all of your findings right onto your XY axis. Okay, so you know this is your X, this is your Y. Okay, so now what? Let's go ahead and plot the original. The original was in orange. So we have -4, 0. We have -2, -2. Let's put that in blue. Can't really see orange and red that well. Yeah, this is blue, okay? So f of x is in blue now. Okay. All right, so we have -2, -2. So 1, 2, 1, 2, something like that. We have 0, 0. We have 2, +2. And then we have 4, 1, 2, 3, 4, 0. Go ahead and connect your dots. And we have our original. Now let's go ahead and plot the g of x. So we have -4, 0 again. You see it's sharing a dot right there? That's fine. We have -2, +2. So 1, 2, 1, 2, someone right there. Then we have 0, 0 again. And then we have 2, -2. So 1, 2. And then we have 4, 0. So they share 3 points. Let's go ahead and illustrate that. Now take a look. This is what they call a reflection. You see this point here? It used to be down here, right? All they did was reflect it across the x-axis. So whenever you have a change on your y's, whenever you multiply your y's by -1, whenever you have a -1 outside, you're going to flip this across the x-axis, okay? On the flip side, if you have a negative in front of your x, which we will, we're going to have to change all of our x's when multiply them by -1, you're going to flip across the y-axis. So this is a reflection type of problem. So we are done. Let's go ahead and just graph what we have here in green, and we want to match it up with the table that we just made. So let's see, -4, 0. That can be it. This can be it. We start up and go down. Yeah, it has to be A. Nice work. Okay, so we have a reflection on the inside, and we're going to subtract 4 from all of our y's. So let's go ahead and do it. Let me erase all this mess over here. Okay, so we have f of x, we have x and y. Okay, let's get our points. We have -4, 0. We have -2, 3. We have 0, 0. We have 2, -3. And then we have 4, 0. We have a g of x. G of x is going to be equal to f of -x and then -4. And we have a little xy table going on here. Okay. Well, what are we going to do? Well, let's take a look at the inside. Do we have anything happening inside? Of course, we have a -x. We're going to multiply. I told you it was going to pop up. We're going to multiply all of our x's by -1. So let's do that. We have -4 times well, let's go ahead and write down the steps. So multiply x by -1, just so we know our steps. And while we're at it, for the y's, we're going to subtract 4, right? Whatever happens outside, we take it as it is. No funny business. So we're going to subtract 4 from y's. Okay, so let's do it one step at a time. So let's go ahead and multiply all of our x's by -1. So -4 times -1 is 4. -2 times -1 is +2. Basically, we just changed the sign. 0 times negative 1 is still 0. There is no such thing as a negative 0, positive 0. Change the sign, change the sign. There goes all of our x's. Now for the y's, we're going to subtract 4 from all of our y's. So 0 minus 4 would give you negative 4. 3 minus 4 would give you negative 1. 0 minus 4 would give you minus 4. Negative 3 minus 4 would give you a negative 7. And then we have 0 minus 4 again, which will give you negative 4. That's it. We're done. So let's go ahead and match up our points. We have 4 comma negative 4, so 4 comma, that could be it down there for A. Mind you, we have a reflection going on, and we have a negative across our x. That means we're gonna flip across the y-axis. You see how weird that is? Last time we had a negative outside for our y's, and we flip across the x. But now we have a negative across the x, we're gonna flip across the y-axis. So when you have a negative in front of your y, you flip across the x-axis. When you have a negative in front of your x, you flip across the y-axis. Jot that down, memorize it, do what you have to do. It'll be helpful. Okay, so we have 4, negative 4. That could be it. It's not going to be C. It's not going to be D. It could be B or A. They look very similar, right? So let's go ahead and see if we can enlarge it. 4, negative 4. So 4, yep, there it is right there. 2, negative 1. Nah, it's not it. We need all of our points. Let's go to contestant number 2. We have 4, negative 4. Bam. We have 2, negative 1. That's got to be it. And the other points are there as well. We have 0, negative 4. We have negative 2, 1, 2, negative 7. Yeah, that's got to be it. It's as simple as that. So we changed our x's, we changed our y's, and we're good. Keep going. Okay. Over here, we're just going to multiply all of our y's by, because it's outside, right? The 4 is outside. We have g of x equals 4 times f of x. This is your f of x. This is your original. And your new function, your secondary function, will be all of your y's times 4. And that's it. And your x's are going to stay the same. So let's go ahead and handle business. Because remember, inside changes x, outside changes y. Let's go ahead and get our original points here. And you're going to see we're going to make really quick work of this one. Oh, and whenever they multiply by a number outside where your y's are, that's called a vertical stretch. It gets taller. You're going to see, don't multiply something by a number makes it larger, right? Mind you, if you're going to multiply it by a fraction, it's going to make it smaller, because multiplying by a fraction, isn't that like dividing? So that's actually going to cause a shrink. We may or may not deal with that today. Who knows? Okay, f of x. We have A, and they were nice enough to write it for us. So we have negative 5, 0. Okay, negative 5, 0. Negative 3, negative 1. We have 0, 0. We have 3, 1. And 5, 0. I don't like the way that 0 looks. Okay, g of x. So for g of x is equal to 4 times your f of x. This is outside. It's an outside change. This is 4 times f of x. So you're going to take all of your y's and multiply them by 4. There is nothing going on in here inside the parentheses, so nothing's going to happen to your x. So your x's are going to stay the same. So let's go ahead and write all of our x's as the same. Negative 5, nothing's going to happen. Negative 3, 0, 3, and 5. Okay, what about our y's? We're going to take all of our y's and multiply by 4. Ready? So 0 times 4 is 0. Negative 1 times 4 is negative 4. 0 times 4 is 0 again. 1 times 4 is 4. And we have 0 times 4, which we know is 0. This is our new graph. So we want to make sure that they correspond. And let's go ahead and make a little XY axis. Why not? We haven't done it in a little while. So 1, 2, 3, 4, 5. Let's do a 5 by 5 because my highest number is 5. It's a negative 5, but you know, still technically the largest number. May not be the greatest, but it's still the largest. You know what I mean? Like the magnitude of it is a 5. Okay, so we have negative 5 comma 0, which is right here. We have negative 3 comma negative 4. So 1, 2, 3, 1, 2, 3, 4 right there. We have 0 comma 0. We have 3 comma 4. So 1, 2, 3, and then 1, 2, 3, 4. Then we have 5 comma 0, 1, 2, 3, 4, 5. So we should get something that looks like this guy. So let's match it up. Which one do you think it is? It looks like it could be, it could be B or D. Now remember, this is a, this should have been a stretch, so it should have gotten longer. So we're just gonna click and match up the points anyway. We don't have to guess or anything like that. We can use our best estimated guess if that's your last resort, but we have the actual numbers exact to the very down to the very nitty gritty detail. So we have negative 5 comma 0, bam. We have negative 1, 2, 3, and then negative 4. Got it. We have 0 comma 0. Yeah, it's got to be it. We have 3 comma 4. Got it. And we have 5 comma. Yep, that's it. This is B, my friends. Fantastic. Okay, so now we're going to start describing things. Go ahead and shake off those last few functions. You got through the very hard parts. And they're just going to build from here. Okay, so now we have to, with English, we have to describe what's going on here. So now, as you can see, we're dealing with, this is considered a parabola because we have the parentheses being squared. You're going to see absolute values. You're going to see square roots. You're going to see to the third power, the third root. You're going to see all of that crazy stuff. And we'll just tackle it as we go. So it says use transformations of the graph of f of x equals x squared to determine the graph of the given function. So we have x minus 6 squared. Now we have something going on inside. Remember, that rule has not changed. Whenever you have something inside, that's going to change your x. So let me write that down. Inside changes x. And outside changes y. That's never going to change. In all of these cases, that's never going to change. Oh, and another thing for the inside portion, remember we want to do the opposite, just in case there's any pluses and minuses. Like if you have a plus 4, minus 4, you want to do the opposite of what you see there. Okay, very tricky math can be. This is what makes math tricky. A small detail like that, like, oh, just do the opposite of what you see for your x's on the inside. Whatever, it's not the end of the world, okay? So what's going on here? The only thing that's different from x squared and x minus 6 squared is that we have a negative 6 sitting in there, right? You can imagine if there's a parentheses around just the x. So if you have f of x is equal to x squared, technically, wouldn't this be technically the same thing if you were to wrap a parentheses around it? Just the x, excluding the 2? So we never really see it like this. We just call this x squared. We never write the parentheses around just the x, but we're going to pretend that the x is being wrapped up in parentheses for now. So you see I left a big space. That's where they put the minus 6 in. They just sneak it right in there. So that's definitely going to be inside of the parentheses, right? So it's going to change your x. And how can it not change your x? It's right next to it physically, right? So think of it that way, you know. Get into the habit of, you know, just get the idea of what's going on here. Anyway, we have minus 6. It changes x. So we're going to have a horizontal shift. But we also do the opposite. So it's a negative 6. Normally negative would be to our left. But because we know to take the opposite, this is actually going to be to the right. So this is going to be 6 units to the right. Because it changes the x. This is the x-axis. Remember, the x-axis runs this way. Right? The x-axis is this guy here, running left and right. So it's horizontal and it's positive. So 6 pushes to the right, and that's the only thing going on here. Excellent. Okay, now they want us to graph the darn thing. And, okay, it says use transformations of the graph f of x equals x squared. So I'm going to give you some guidelines. So remember last time when we took the f of x and we just went ahead and we got the original points. The original points, it is possible to memorize them, okay? And they're very simple. So just for now, we're going to start with -2, -1, 0, 1, and 2. I call these the magic numbers. Usually these magic numbers work for most functions with absolute values. It won't quite work with square roots because we can't take a square root of a negative, but you're going to see we're going to have magic numbers for those too. But you want to use -2, -1, 0, 1, and 2. So remember that f of x, your original function is f of x equals x squared. This is what the x minus 6 squared is based around. These are the magic numbers. So all you do is plug these numbers into there to get your y's. And if you study before reading this video, you'll know that this is a U shape. This is a parabola. It's going to look something like that. And you're going to see how it works out. Anyway, so let's plug -2 into the x squared. Wouldn't that be -2 parentheses squared? So even though we didn't have a parentheses to begin with here, we want to make our own parentheses. So this is f of -2, which means we're plugging in -2, and we get -2 squared. So when you start plugging numbers into a function, you want to put parentheses around that number you're plugging in. Very important. So -2 squared, this is basically -2 times itself. You know, a negative times a negative is a positive. -2 times -2 is positive 4. We're going to do the same thing with -1. We're doing -1 squared. Oh yeah, before we do that, I don't want you to say that this is just when you're plugging into here. I do not want you to say this is -1 squared with no parentheses, because this is going to give you a completely different answer. This will be -1. But no, whenever you're plugging a number in, we're plugging in your x so we can get a y out, right? I want you to put whatever you're plugging in parentheses, okay? Very important, because -1 squared is a positive 1, isn't it? It's a negative times a negative. So this is a 1. 0 squared, 0 times itself is 0. 1 squared is 1, and then 2 squared is 4. So these are the original points of our parabola, okay? This is the x squared parabola. So I guess I'll do a line xy axis for now. Okay, so let's go ahead and plot our points for the original f of x. And this is true for every single function that has f of x equals x squared. You know, bare bones, no pluses, no minuses, nothing crazy. So 0, 0, -1, 1, +1, 1, -2, 4. So 1, 2, 3, 4, somewhere right there. And then we have +2, 4. And we're going to connect the dots from both sides. And it's going to keep on going in that direction. It's going to keep on going in that direction. And look, we got our u. This is the original function of x squared. Now, take a look at the g of x that we had a little while ago. So we have g of x is equal to parentheses x minus 6 squared. So we're going to have his own xy table. Now, based on what we have over there on the left, what's going on here? We're doing 6 units to the right, so we're going to add 6 to x, to all of our x's. Now, there's nothing going on with the y, so I guess it's safe to say that we're still going to have 4, 1, 0, 1, 4. You can fill them in. Why not? The y's aren't going to change. You can write them down. But our x's, we're going to add 6 to all of them because it's the opposite of what this is. So it's 6 units to our right. So 4 plus 6 will give you 10. 1 plus 6 will give you 7. 0 plus 6 will give you 6. We get 7 again. And, oh, what am I? Oh, we're supposed to be adding to x's. I was looking at the y's. Okay, -2 plus 6 will give you a 4. -1 plus 6 will give you a 5. 0 plus 6 will give you 6. 1 plus 6 will give you 7. And then 2 plus 6 will give you an 8. So that is our new function. Okay. So it's the original function shifted over 6 units to your right. So, you know something, I want to try something a little bit different. I'm just going to make a few more extra tick marks here. I'm going to graphically just move every single dot from our original 6 places to the right, and you're going to get the same result. It's as if you're plotting this by itself. So looking at this middle right here, let's go 6 units to your right. 1, 2, 3, 4, 5, 6. Mark it. From here, 1, 2, 3, 4, 5, 6. From here, 1, 2, 3, 4, 5, 6. Up here, 1, 2, 3, 4. Yeah, you get the idea. It's gonna be something like that. This will be 8, comma 1, 2, 3, 4. Yeah, 8, comma 4. And then we have 4, comma, so 1, 2, 3, 4, 5, 6. That's if you want to be slightly, sloppy, if you want to be an artist. So there goes our new parabola. And it corresponds to this. Don't, fear not, fear not. This is 1, 2, 3, 4, 5, 6, comma 0. We have 7, comma 1. We have 5, comma 1. We have 4, comma 4, which is right here. And then we have 8, comma 4, which is way up here. We're done. So let's make sure that we put this inside of the graphing tool correctly. It says use transformations to determine a graph of the given function. Now, sometimes they want us to write the original function. Sometimes they just want us to graph the f of x. Let's see if I don't see any instructions here. It just says graph the function. So we're just going to do g of x, the final thing. So very important. Okay. Usually they want that middle number, the one right here at the bottom. That would be 6, comma 0. Oh, looks like they didn't. Okay, so normally we're supposed to find it ourselves, but you know what? We're just going to specify what the shift is, and this is a horizontal shift. And what kind of shift is it? This is a positive shift. So this is positive 6. So just put a 6 here underneath the horizontal shift box. Let's hit enter. There it is. It's the same exact thing. You can see everything, right? We have 6, comma 0. We have 5, comma 1. This is our parabola that we just created. So I guess they were nice. They were nice about it. They gave us a little tool that we just put the shift, and we got it fantastic. You're going to see they can switch the game up very quickly. So they may make us do our own stuff, but for now, it should be smooth. Okay, so looking at this, let's erase this mess. Okay, so looking at this, we have a negative on the outside. That's going to change your y's. We have minus 3 on the inside. We're going to add 3 to all of our x's, which is a horizontal shift to your right. So let's write down what we have. We're going to reflect. Now, you have a y outside of the outside changes your y. You have a negative in front of your y. So remember, the opposite sign of y is your x. So even though you have a negative next to your y, you're going to reflect across the x-axis. Remember that? We're going to add 3 to all of our x's. The x-axis is left and right. So this is a horizontal shift. Where is it? It should be to the right. There it is. Just those two little things. Bam. Excellent. Now let's go to click to enlarge graph. Hit the parabola button because we have x squared. I guess you can put it anywhere. I don't think it matters. Okay, so now you don't have to, it doesn't matter what you do first. We know we're going to reflect across the x-axis. The x-axis. So yeah, it should flip upside down, and we're going to shift to the right 3 units. So horizontal shift. Let's see, erase this and put a 3. Hit enter. Yeah, that's it. So it reflects down, and then it goes 3 to the right. Hit the X, hit save, and that's it. Okay, same deal. So we have, remember the opposite, we're going to add 5 to your x's. It's going to the right if you're adding to the x, so that's going to be a shift to the right. There it is, so many categories. Outside changes your y. That's 5 added vertically going straight up. Where is it? Yeah, 5 units up. That's it. Just those two, nothing else, right? No negatives or anything like that. Excellent. Click to enlarge graph, parabola. Let's see if it matters where I click. No, it doesn't matter. You can click anywhere you like. So a horizontal shift of positive 5. and a vertical shift of positive 5 as well. Let's see, raised to 0. All right, hit the X. Yeah, so it started from here, then it went right 5, up 5. Yep, that's it. Save. Yeah, we got it. Let's keep going. This is fun, right? Now, here's where it gets a little tricky. Once again, we're still going to have a horizontal shift of the opposite of this, which is -4. So let's do that first. So shift 4 units to your left. There it is. The outside, we're going to shift 2 units down because it affects your Y. So 2 units down. And over here, this is what they call a stretch. Multiplying something by a number increases its magnitude, which makes it stretch vertically. Okay, so we need to look for a stretch. Yep. So stretch the graph vertically by a factor of 2. Seems legit, right? Got it. We got all 3 of those little things. 3 different numbers. So we have 3 different translations and transformations. Okay. The translation is the shifting, up and down shift, vertical, horizontal. That's the translations. The transformation would be like stretching and reflecting. They may just say transformation is a one-size-fits-all, so everything is a transformation, I suppose. I'm not too big on the semantics. But anyway, this is a parabola because we have x squared. Click anywhere. And this is going to be a vertical stretch of 2. So we're going to slide this little dial to 2 like that. And it's a vertical shift of -2. So let's put -2 here. Horizontal shift of -4. Put -4. And we're done. Hit the X. Hit save. Bam. Oh, what happened? Okay, I hit check answered and it brought me back. Good job. That was weird. Anyways, now we have a square root function. This is your square root function right here. Y equals square root of x. These are the magic numbers. Now you can't really tell what the magic numbers are, but I'm gonna tell you right now. I'm gonna show you. So the square root function is the only function that we learn is very finicky. You have to be very careful what you write in there. So we have y is equal to the square root of x. So you remember that the square root inside of a square root cannot be negative. Remember that section from a few chapters, like maybe a chapter or 2 ago? When you make your xy table, right? It's going to have its own magic number. So we can't use -2, -1, 0, 1, and 2 again like we did last time. We're only going to plug in perfect squares so that they're nice. Now remember, you can take technically we can put a 2 here. Technically, the square root of 2 is like 1.44, something crazy like that. I forgot. 2 is not a perfect square, so it's kind of useless. However, we can start with 0. We can put a 1. And let's just count up. We're going to get a few just so we can get an idea of what we're allowed to plug in for the square root function. Let's see, 0, 1. We can't plug in 2. We can't plug in 3 because there is no square root of 3. That's a perfect square. We can plug in a 4 because the square root of 4 is 2. So that's a nice clean number. Let's see, 5, 6, 7, 8, 9 is a perfect square. And we're going to stick with this. How about one more perfect square? 9, 10, 11, 12, 13, 14, 15, 16. Yeah, you can't take the square root of 16 because we know the square root of 16 is 4. So what are our y's? Well, to get your y's, you plug in your x, right? So here will be the square root of 0, which we know is 0. Then we have the square root of 1 is 1. The square root of 4 is 2. So remember, we're plugging in here. This is what we're doing. We're just plugging in your x's and trying to get a y out. Square root of 9 is 3. The square root of 16 is 4. So here is our original function for f of x. And notice that I put a y equals f of x. Did you know that y is just like saying f of x? Did you know that? Oh. Okay, fail. That was horrible. Okay, this should be an x, and then this is what I was trying to do. It's still ugly, but f of x is just like y. So instead of saying y, you can say f of x instead, and they mean the same exact thing. Because by definition, y is the function of x. All right, let's go ahead and erase the computations. So here is our original square root. We can go ahead and graph it just like they have. And that's basically the graph that they have there. So I do by 9, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so first is 0, 0. I want to put it in red. Then we have 1, 1. Then we have 4, 2. And then we have 9, 3. So 1, 2, 3, somewhere right there. And basically, this looks almost like a shooting star. Some people have said that it looks like a Nike check. And you can see right over here, where on the graph for my math lab, it's the same thing. That's the idea. It starts from 0, 0, and it just shoots out. And it goes forever and ever. You see the arrow at the end of the graph. That means it goes infinity in that direction, positive infinity. So that's the idea for square roots, and a square root can have its own transformation. Now, look at what we have here. We have h of x. Now, normally we have f of x and g of x, right? But guess what? That second function can have any letter in front of it. It can be a g, it can be an h, it can be an I of x, like it can be a q of x. It basically means the second function. So that's what we're going to do here. We're going to graph the second function. So we have h of x is just equal to the square root of x plus 6. So what do we do here? Do we have an inside and an outside? Yes, we do. We have something that's inside of the square root symbol. This guy is inside, right? So last time we had parentheses. This time we have a square root symbol, a radical. So yeah, it's still considered inside something. And we're going to use the same exact rules. The inside changes your x. We took the opposite of what we see in there. So this is a plus 6. So we're going to minus 6 to all of our x's. There's nothing outside. So all of your y's are going to stay the same. So I'm going to put h of x here. I'm going to give it its own xy table. Your x's. You're going to take all of your... Oh, let's put our y's. The y's are going to stay the same. So 0, 1, 2, 3, 4. And you know what? Let's look at it differently. Okay? How about we just, according to the shifts, we just use the shifting rules and just move that way. Just count from the dots themselves. So we know we're going to go 6 places to your left because we do the opposite of what we see here. It's negative 6. So we're going to subtract 6 from all of our x's. So from 0, 0, just go 1, 2, 3, 4, 5. Hold on. I lost count. 1, 2, 3, 4, 5, 6. From here, 1, 2, 3, 4, 5, 6. From here, 1, 2, 3, 4, 5, 6. So look, it's going to be another shooting star doing something like that. Okay. You can see this is just a rough sketch. I didn't even make the table for that. But you know, you're going to do 0 minus 6, which is negative 6. You do 1 minus 6, which is negative 5. 4 minus 6, which is negative 2. 9 minus 6, which is 3. 16 minus 6, which is 10. So they should all have that. All those points would be along this blue line here. And the y's are going to stay the same because there's nothing outside the function, the secondary function. And that's it. So let's go back to reality. That's the introduction of square roots. What do we have? All we have is a horizontal shift going to your left. So am I blind? There we go. It was at the bottom. I wasn't looking at the bottom. Excellent. Okay, so which one closely resembles ours in blue? It'll be, looks like this guy. This is the only one that shifts over to your left. So, nice work. So far, so good. All right, so take a look at this. What do we have inside? We have a positive 2, which we know we're going to do the opposite of that because it's inside. It's going to change our x. It's going to be horizontal. So this is negative 2, and it's 2 units to your left. What's going on outside? What's affecting our y's? We have a negative 1 multiplying to all of our y's, which means that if it was positive, it's going to be negative. If it was negative, it's going to be positive. That means it's flipping across the x-axis. So remember, the negative in front of the letter means you're flipping across the axis with the opposite letter. So if you have a negative in front of your y, you're going to flip across the x-axis. If you have a negative in front of your x, you're going to flip across the y-axis. So let's do this. Reflect the graph about the x-axis. And that's it, just those two things. Okay, so how do we reflect that? So going back to the original. So you remember the original is in red. We can do it from here. Let's go ahead and flip across the x. I'm just gonna piggyback off what I did last time. Just ignore the green graph for a second. We're gonna flip across your x, so I'm just gonna do a little rough sketch. So it should be like, here's your x-axis here, right? Let's flip across your x. So it should be like that. That's the reflection across the x-axis. You start from here, you go down here, right? The x-axis is your mirror technically. And then from here, let's shift 2 units to your left. So from here, we're going to 1, 2. From here, 1, 2. Here, 1, 2. Yeah, so it's going to go that way. So let's make it nice and solid. That thing should look something like that. Do we have any candidates? I think we do. Looks like choice C. Looks like it might be. Yeah, because let's go ahead and open this up. Yeah, you see in our graph, we're still on the x-axis. We just went to the left 2 units that way. This one looks very similar, but no, we need something over here going 2 units on the x-axis. We're still on the x-axis here, right? This shifted down, so it's got to be this one. You see, I didn't even take the time to make a XY table for that, but you can if you like. Based on the original f of x graph, or the y equals square root of x graph, right here. All right. We have a negative in front of our x, and we have a -4. Hate to do this to you, but all right, it's not the end of the world. I haven't been completely honest about I've been honest, but it was like, to get you up to this point, I think you're ready to get the full truth now. Okay. When it comes to translations, when it comes to horizontal shifts in particular. So let's take the function here. H of x is equal to the square root of negative x minus 4. Now, last time I told you, hey, if you have a -4 in there, you're just going to do the opposite of what you see, and it's a +4, right? Yes, that is true. But we have an elephant in the room. We have a negative in front of your x. So we're going to have to do something there. And the last example that I gave you, remember I told you, remember when we used the factor that we have x minus 2 is equal to 0? Or yeah, remember we have something like this and we say it's the opposite. In actuality, what you're doing is you're setting these equal to 0 and solving. You're not just taking the opposite. Get into this mindset now. Okay. You're not just taking the opposite arbitrarily. Okay. What you're doing is you're setting everything that's inside that parentheses equal to 0. So just to spice it up, let's put a 3 here. So that'll be 3x minus 2 is equal to 0. So we're going to solve for x. So we're going to add 2, for example, add 2. We get 3x equals 2. So x is equal to 2 divided by 3 when you divide both sides by 3. Like that, I know you know. But how does that pertain to? Oh, over here, yeah, you subtract 3. You subtract 3, so x is equal to -3. And I know all this time we just say, oh, it's just the opposite of whatever this is. But no, what you're doing is you're setting everything inside that parentheses, everything that's inside equal to 0 and solving it. And that's how we're going to get the horizontal shift here. So this is the truth laid out in the open. To get the horizontal shift, okay, to get the horizontal shift, you set whatever is inside equal to 0 and you solve for x. This is the truth. This is going to help you in trigonometry and your other math classes. This is the real deal. So if there's still people saying, oh, just take the opposite, they're saying it to not, I guess, to not scare you away from it. But now that we built up a rapport, now that we're here, this is how you find a horizontal shift each and every single time. Okay. So let's go ahead and solve for x. We can add 4 to both sides. You get negative x is equal to +4. And now we didn't come all this way for a negative x. We want to get rid of that negative by multiplying both sides by -1. Or we can say we're dividing both sides by -1. I like to divide. I'm stuck in my ways. So you get a +x is equal to -4. So check this out. Whatever your x is equal to at the end of the day, that's the type of shift you have. This is a -4, so this is a left shift. Okay, so get into the habit of, solving whatever's inside there, set the whole thing equal to 0, the whole thing in its entirety equal to 0, and solve for x. Whatever your x is equal to, that's the direction you're going to go in, and this is true each and every single time. On your exam, I don't want you to say, oh, I have a -4 here, so we're just going to shift to the left and take shift to the right and take the opposite. No, very important, okay? Solve for the whole enchilada on the inside for your x. You can't go wrong. Anyway, do we still have a reflection? Yeah, whenever you have a negative in front of your x, that's always going to be a reflection. The opposite letter of x is y, so that's a reflection across your y-axis. Oh, it's saying, what do we do first? Do we shift first and then reflect, or do we reflect and then shift? In my life, I've always reflected and then shift because, just like in the order of operations with the please excuse my dear Aunt Sally, for you people who know about that, we do multiplication first and then we do addition and subtraction next, right? So multiplication, division, and then addition or subtraction. Because the reflection is technically you're multiplying by -1. It's a multiplication, and multiplication comes first, so you want to do that first. So we're going to reflect first, and then we're going to shift later. I hope it works out. So first we're going to reflect across the y-axis. Do I even see that option? Reflect across the... I don't even see the option. Am I losing my mind? Oh, I guess it doesn't matter in this case. Yeah, they don't... Okay, I don't even see multiple... I don't see multiple answers here, so I think we're in the clear. I don't think it matters. But, when you have a teacher and they tell you that, oh, you do it this way each and every time, and then you find out that you have some leeway in there, you're like, wow, you didn't have to drill that into my brain. Anyway, let's just find what we need. We know we're going to shift across the y-axis. I'm sorry, reflect across the y-axis. And our x end up being negative, so we're going to go to the left. And that's it. One second. First. Let's see. First, reflect the graph about the y-axis. Oh, here it is, right here. That's it. The way that they show us what I have here is equivalent to what they have over there. So, look, the way that I showed you, just to suit them, okay, because we both have the same exact thing. We have a left shift and we have a reflection. You're gonna get the same exact thing, okay. It's just for this particular program, which doesn't want us to be great. They want you to keep this thing going where you said, okay, I'm going to take the opposite of whatever's over here, which will be a +4, which is 4 units to your right, and then we're going to reflect it. But essentially, this is the same thing. If you shift to the left 4 and then reflect, it's going to be the same thing. If you reflect first and then shift to the -4, you're going to get the same result. Sometimes I don't. All right, so which one are we going to do? Well, if you start from, this is the square root. If you start from there, and then we're going to shift 4 units to the right, 1, 2, 3, 4. And then we reflect across the y-axis. Here's the y-axis. You're going to reflect across the y-axis, so you're going to be over here instead. So we should have something going just like that. This is D. I don't like the semantic parts of math, but we got it right. So we're going to play by the rules for now, okay? We're going to stick with what we've been doing. If we have a negative in there, we're going to do the opposite. And then we'll do that first, and then we'll incorporate the reflection. It's kind of like it's crapping on everything I just taught you. Anyway, let's do this one. So inside, we're going to shift 4 units to your right. So the beginning should be somewhere over here, or it could be there. So imagine, let's go ahead and erase this. So 0, 0, got 4, 2. So there is our original. Now we're going to shift 4 units to your right. So 1, 2, 3, 4. So we have something here. And then we're going to stretch it. So we're going to multiply all of our y's by 4. So if you're stretching, you should be going upwards like that. It should get taller. So which one of those closely resembles what we have here? It's got to be A. Excellent. So you see that even without getting the original points and plotting and doing all that long stuff, you can have a general idea of the transformations and everything and just go from there. All right, let's keep going. Absolute value. An absolute value, the absolute value of x is a v. You're going to use the same magic numbers we used last time, -2, -1, 0, 1, 2. We're going to plug them into here to get our y's. -2 inside for x will give you the absolute value of -2 is 2. The absolute value of -1 is 1, and 0, 1, 2. So at the end of the day, when you graph that thing, so we'll do a 2 by 2. When you graph it, you're going to have 0, 0, -1, 1, +1, 1, -2, +2, +2, it looks very similar to a parabola, but this is a sharp V. To help you remember, you can think of V as being, V's the absolute value. The word value starts with the letter V, so V, absolute value, V, right? So make that correlation, do what you have to do. So this is how the original absolute value looks like. Now, what about the changes? We have a -3 on the outside. That's going to change your y's. So we're going to shift down 3 from our original. So starting from 0. So 1, 2, 3. 1, 2, 3. 1, 2, 3. Yeah, we're going to have another V doing something like that. And it shifted down because the outside had -3. So this is a vertical translation. And it should be shifting down. Yeah, that's it. So we have a V that's slightly below. Here it is so you can see it better. So we start from 0 and go 1, 2, 3. So there it is. And our graph was a little bit smaller, but that's the main idea. You want to make sure that spike right there is going down 3 units, along with the other plots, the other points. Well done. Okay, what do we have inside? -2. So we're going to go 2 to your right. Excuse me. We're going to go 2 to your right. And outside changes your y. We're going to go down 4. So we're going to do a horizontal translation because we have something going on inside affecting our x's. And outside, we're going to do a vertical translation as well because it affects our y's. Well done. So starting from 0, let's go right 2, down 4. Looks like that's the only one that does it. Let's see. Starting from 0, do we go right 2 and then down 4? Yeah, got it. It's got to be this one. This one looks similar. Let's just take a glance. Do we go right 2 and then down 4? No, we're missing it. That's right 4, down 2, so be careful. They will give you that as well. But we know our answer is D. Check answer. Got it. Okay, a few things going on here. We definitely have a horizontal translation. So horizontal translation. We have a vertical translation. And we have a reflection. But what is it multiplying with? It's multiplying by our y's because it's outside. And because we have a negative in front of our y, we flip across the axis with the opposite letter. The opposite letter of y is x. So that's it. Okay, so let's reflect all of this. How is all of this reflected? So I like to do, we can do the shifts first, and then we'll reflect, okay? So we're gonna go left 2, down 3. So you know what? Let's draw it this way. All right, so we have 0, 0, we have 1, 1, negative 1, 1, we have 2, 2, negative 2, 2, we have 3, 3. Remember, you can use y equals absolute value of x and start putting in whatever you want for, remember those magic numbers from negative 2 to positive 2? You can go from negative 3 to positive 3 and negative 4 to positive 4 and just put any numbers you want. Okay, but what do we need? We're going to go to the left 2, down 3. So 1, 2, down 3. Coming from here, 1, 2, 1, 2, 3. So look, you're going to have a V that looks like this. And we'll make it dotted. Okay, that's only the translation part, only the shifts. And now at the end, now we're going to reflect across the x-axis. So here's the x-axis. And now if we're 1, 2, 3, if this is 3 down from here, then we're going to go 3 up from there. We'll make it in red. So 1, 2, 3. We should basically have an upside down V, okay? If you reflect that across the x-axis, it should be the reverse. It should be the flip version of this one here. And I think we got it. So it should look something like that. So an upside down V that's going to the left 2 and then up 3. Okay, so let's see which one closely resembles that. Reflect across your x. Oh, I made a little boo boo. Reflect first. We're gonna reflect first, and then we're gonna shift. So here's where we start. Reflect first. And I had just said that a couple of minutes ago. Reflect first, and then we apply the shift. Left 2, down 3. Left 2, down 3. So we're here now. Something like that. Let's just keep moving. Sorry about that. Okay, anyways. Horizontal shift. Yeah, that last problem from a while ago that tripped me up when I started getting the questions wrong. That last problem got me second guessing life a little bit, but I'll get back on point. This is a vertical shift. You're gonna get it. You gotta get them right. Vertical stretch. Sorry. Let me concentrate. I still gotta concentrate. Okay. Because we have a number multiplying. That's a vertical stretch. Okay. So left 2. So if you start from the XY axis, starting from here, you go left 2. So you're gonna be somewhere here, right? And then it's going to stretch, so you can imagine those V's getting even tighter than what they were before. And let's make that in blue. So if you have a wide V like this, if you're stretching it, it's going to get higher towards the ceiling. So it's going to go something like that. So which one reflects that the most? I would say this one over here. Our vertex, remember the corner here is called the vertex. The vertex is right over here to the left. So it could be D or it could be A. Now which one looks skinnier? It's this one. Good job. And that's how we process them. Okay, so it's not gonna catch us off guard this time. I'm gonna reflect first and then I'm gonna do the shifts. Freaking. Okay. Oh, and we also have, let's go ahead and put what we have here. We have a horizontal shift because of the +6. So horizontal shift. We have a vertical shift because of the +2. And we have a reflection across the x-axis. And we're going to have a stretch, a vertical stretch. It's always going to be vertical, okay? Not horizontal. Nice work. Okay, so how do we tie all this together? Well, you know that the absolute value starts somewhere here. So we'll just put the original, something like that. And we're gonna do different colors to make it more easy to comprehend. We're gonna reflect first. So let's reflect first. So we're gonna go down this way. And we're reflecting across the x-axis, by the way. Then we're gonna go ahead and apply. I guess we can we can go ahead and apply the horizontal and the vertical. We're gonna go left 6 up 2. So 1, 2, 3, 4, 5, 6, and then 1, 2. So we're gonna be somewhere here, still pointing down, because all we did was shift over. And then as for the stretching, well, I meant to make that a different color. Let's go here. And as for the stretching, it should get more narrow. So let's just imagine it getting more narrow like that. A more narrow V. So right here in red, that's where it should be. That's what it should look like. So which one closely resembles? It's got to be C. Look at that. So go step by step. Do it just like that. Do the reflections first. Do the shift second. And then you can make it narrow or, based on the stretch. And that's it. Okay, determine the graph. Okay, now we have x plus 3 to the third power. It's just like what we've been doing. We're going to have a +3 on the inside, so we're going to have a shift horizontally to our left. So what does it look like? Last time when we had the square, we had the parabola. But now that we have this risen to the third power, we're going to have a snake. That's what I call it. It's like a curvy little, it starts down here and goes all the way up like that. That's whenever you have the third power, your parentheses risen to the third power. So here's where it starts: 0, 0, 1, 1, -1, -1. You plug a 2 in there, you get 2, 8. You plug a -2 in there, you get -2, -8. So you can have positive and negative values. Now, what do we need from here? We know we have a +3 inside, so we're gonna go ahead and call that a horizontal shift to your left. So notice they give it to us in the form of a dial now. Hopefully it doesn't mess us up. Oh, okay, it's highlighted. And we want a 3, so let's just slide it down. So you see how they give us a different interface? Is that the -3? Yeah, we're good. So they can switch up their, I guess, their delivery method anyway, any way that they want. Yep, we have a reflection, and it's going to be about the x-axis. So, yep. And we're going to have a left shift that's horizontal. So 5 to the left. I'm looking for 5. Yep, there it is. Just those two things. So we're going to take the snake shape and we're going to reflect it across the X, and then we're going to move 5 to the left. So let's go here. Choose the snake symbol, click anywhere you want. Reflect across the X-axis. Then we're going to shift to your left horizontally. So, all right, it's at -5, so we're done. I'm waiting for it to bring more funny business out. Okay, this is still risen to the third power, so it's the same deal. Snake symbol. Click anywhere you want. Oh, these are just shifts. What do you know? So we have a horizontal shift. It's +2 inside, so we do the opposite, which is -2. The vertical shift, gonna go up 4, so make sure you're in a positive direction. You got your 4, and that's it. Hit save. Check answer. Got it. It's good when we get them right. Okay, so now take a look at this. So this is the third power. I'm sorry, the third root, and it's very similar to the third power, but sideways. So you remember what we have y equals x to the third power, or f of x equals 2x to the third, same thing, tomato, tomato. Remember we have these points. We have somewhere here, then we have 2, 8. You know, something like that. That's the generic shape, right? That's for y equals x to the third power. When you have y is equal to the cube root of x, it's very, very similar, but it's going to be sideways. It's like it's going to do something like you're going to have these same exact points, but it's going to do something more like this, like it's like sideways. So this is just a rough sketch, but just to get you into the idea, all right? It's just a sideways snake, very similar to the other one. But anyway, select all the transformations that are needed for the graph given the function using the original function here. So let's go ahead and figure that out. Now, is it outside or inside? All we have here is an x, so there's nothing going on inside, so nothing's going to affect your x. But we do have a -6 outside of that radical, so this is going to affect your y's, and this is a shift is going down, and that's the only thing. Excellent. Okay, so we need a sideways snake that actually goes down. So you can imagine we go down from here. So 1, 2, 3, 4, 5, 6. We have another point there. We have another point there. We have another point there. So just imagine if you take that, the sideways snake and just shift it down 6 units. So whichever one closely resembles this is our answer. And that's got to be it right there. Fantastic. We have a reflection going on. We're going to reflect across our x, and then we're going to shift to the right 4 units. So, let's go ahead and do a little rough sketch of that one. So you see we've graduated to rough sketches now. You want to be this comfortable when you're going through these, and that's all there is to it. If you know the rules, if you know about reflections, if you just drilled in your head about reflections and transformations and everything like that, shifts, reflections, you can't go wrong. So we're going to have a little sideways snake like that, you know, roughly. Now what? So we're going to reflect across the x-axis because we have a y outside the negative, and we're going to shift to the right 4 units. So reflections first, and then we shift. I'm going to put that in line. So how do we reflect this across the x-axis? Well, here's the x-axis. If it's right here at the origin, it stays at the origin, okay? There's no reflecting across the origin. If the point is 0, 0, it's going to stay 0, 0. You take all of your y's and you multiply by -1, right? So this right here is going to be here. This right here is going to be here. If you have an arrow that's down there, it's going to be up here now. If you have an arrow here, it's going to be here. That's how we actually reflect across your x. So it's going to look something like that. That's it. Because remember, aren't we multiplying our y's by -1? So it should be something like this. Oh, and we're not quite done yet because we still have to shift over 4 units to our right. So 1, 2, 3, 4. And we should have a sideways snake looking something like that. And we use this doing rough sketches. So which one closely resembles our monstrosity here? Definitely that one. You can see we're still on the x-axis here, and we're still on the x-axis right here. So yeah, that's got to be it. Well done. And we got our 100%. Thank you so much for watching this video. The next video is coming up soon. I still have a lot of editing to do, so yeah, see you in the next video. Thank you so much for watching.